Welcome to the Weekly Upside. In a world that can feel heavy at times, this is a place to take a few minutes out of our day and to look at what's quietly going right. Here we talk about positive progress in science, in nature, and in human innovation. And these things often don't make the headlines. Here's what stood out this week. Let's start with the ocean. Some coral reefs are beginning to recover, particularly in areas that have been actively protected. In parts of the Great Barrier Reef and other marine protected zones, scientists have documented significant coral regrowth in the years following major bleaching events. In fact, recent surveys have shown record levels of coral cover in some northern sections of the reef. This kind of recovery is often driven by fast-growing coral species, which are able to regrow relatively quickly when the conditions are right. This doesn't mean that reefs are back to normal. Marine heat waves driven by rising ocean temperatures remain the primary threat, and repeated bleaching events can weaken reefs over time, even when there's short-term recovery. What's encouraging is this. In areas where local stress is reduced through better water quality, less overfishing, and strong marine protections, reefs show much greater ability to recover between these events. Scientists often refer to this as resilience and the ability of an ecosystem to absorb stress and still be able to rebuild. So while the global picture remains mixed, these localized recoveries show that protection efforts are not just theoretical, they're having measurable impacts. And they give a clear picture of what actually helps reefs survive in a challenging and changing environment. Something else that's moving forward is gene editing. You may have heard the term CRISPR. It stands for Clustered Regularly Interspaced Short Palindromic Repeats. And while the name is complex, the idea is actually quite simple. CRISPR acts like a molecular tool that allows scientists to edit DNA with a high level of precision. In simple terms, it can be used to locate a specific gene, cut it out, and modify it. And this is now being used in real-world treatments. In recent clinical applications, CRISPR has been used to treat conditions like sickle cell disease by editing a patient's own cells. In some cases, patients who once required frequent hospital care are now living with significantly reduced symptoms or none at all. It's important to note that this process is complex, it's expensive, and it's still being studied for long-term effects. But it represents a meaningful shift from managing a disease to potentially correcting at the genetic level. And it opens the door to treating a range of inherited conditions in ways that weren't possible before. Moving on to our third story, a large-scale tree restoration effort has started to gain traction globally. Projects are underway to restore degraded land using native tree species rather than using single-species plantations. And this distinction matters because biodiverse forests are more resilient, support more wildlife, and provide stronger long-term benefits. Initiatives around the world are working to restore millions of hectares of land, often involving local communities in planting and long-term stewardship. In some regions, they're also helping to restore water cycles, improve groundwater retention, and stabilize local climates. It's not a standalone solution to global climate challenges, but when done well, reforestation can become part of a broader system that supports both environmental and community resilience. Let's move into a quick update on energy. Battery technology continues to improve, especially when it comes to storing renewable energy. One of the key challenges with solar and wind power is that they don't produce enough energy on a constant basis. Storage becomes essential, and recent advances are improving battery efficiency and increasing lifespan and reducing the costs overall. There is also growing development in alternatives to traditional lithium-ion batteries, including technologies that rely less on rare or difficult-to-source materials. At grid scale, large battery systems are now being used to store excess energy and release it when the demand increases. This helps stabilize energy supply and makes renewable energy more practical at scale. It's a technical shift, but it's one that plays a critical role in how energy systems evolve over time. And finally, one more story to close on. Some endangered species are beginning to stabilize and in certain cases recover. For example, giant pandas were reclassified recently from endangered to vulnerable after years of conservation work. And certain tiger populations have also shown growth, particularly in regions where strong protection measures have been put in place. These improvements don't happen quickly, and they're a result of long-term efforts, including habitat protection, anti-poaching enforcement, and ongoing monitoring. And in many cases, local communities are also involved, which increases the sustainability of these efforts over time. Globally, biodiversity loss is still very much a concern, but these examples show something important. When protection is consistent and strategies are sustained, species can recover, and ecosystems can begin to rebuild themselves. Remember, folks, that progress doesn't always make the headlines, but it's still happening quietly, consistently, and in ways that add up over time. This has been the Weekly Upside. Thanks for spending a few minutes here, and we'll see you next week.